Okay, we're going to talk about the triangle sum theorem and the exterior angle theorem. The triangle sum theorem talks about if I add up all three angles in a triangle, it's going to be equal to 180 degrees. Okay, I think that's a concept that's learned in junior high, but we're just going to expand upon it here. All right, the next concept is the exterior angle theorem. And what it says is this exterior angle here, if I extend out an edge and it creates an angle, that exterior angle there, it is equal to the sum of the two opposite interior angles. So the measure of angle 2 plus the measure of angle 3. Okay, so let's do some examples. All right, so we're finding all missing angles. If you look at angle 1, we're talking about all interior angles, so the triangle sum theorem would be helpful here. We know that all three angles have to add to 180 degrees. Okay? So if I take 180 degrees and I take away the 24 that I've used up, and I take away the 37 that I've used up, the remainder that is left over when I do that subtraction has to be angle 1. Okay, it's what's left over. Okay? So you're doing the opposite operation. If all of them add up to 180, I'm going to subtract things away to get it there. And so when I do that, I will get 119 degrees. Okay. You can also set up an equation if it helps you to solve it. 24 plus 37 plus measure of angle 1 is equal to 180, and solve for that measure of angle 1. And in doing so, you'll subtract 24 and subtract 37. Now this one doesn't have all interior angles. My angle 1 is an exterior angle. So I'm going to use the exterior angle theorem, which is right above. And it says that that exterior angle, measure of angle 1, is equal to the sum of the two opposite interior angles. So 76 and 52. When I add those together, I get 128 degrees. All right. Our angle 1 here is an interior angle, but we're dealing with an exterior angle. Okay, I don't have that third interior angle, so we'll use the triangle sum theorem or exterior angle theorem. And so measure of angle 1, my interior angle, plus the measure, or plus 79, has to be equal to that exterior angle, or as the theorem would write it, 104 is equal to those two interior angles being added. Doesn't matter the order that you do it. But in that case, I want to solve for the measure of angle 1, and I'll subtract 79 for both sides. The result of that would be 25 degrees. Okay, so then if we start combining triangles together, we may have to use a combination of theorems. We're going to be finding three angles, measure 1, angle 1, measure of angle 2, and measure of angle 3. All right. If I try to find the measure of angle 1 first, if you notice in this triangle here, you have all three interior angles. So I know that the measure of angle 1 plus 66 plus 84 has to equal 180 degrees. So I can subtract 66 from both sides and subtract 84 from both sides. So then that result will leave me with the measure of angle 1, which is 30 degrees. Okay. Then if I'm moving on to the measure of angle 2 and the measure of angle 3, it's actually going to be a lot harder to find measure of angle 2, but measure of angle 3, it's an exterior angle of that purple triangle that I looked at. And so I can use the exterior angle theorem. The exterior angle theorem says that that exterior angle, measure of angle 3, is equal to the sum of its opposite interior angles. So 66, and the measure of angle 1, which I know is 30. The measure of angle 3 is 96. Okay. Well, now, if this is 96, I have all three angles in that triangle that I didn't trace around over there. I have measure angle 2, 96, and 43. And I know that the measure of angle 2 plus 96 plus 43, all three of those angles have to add to equal 180. So I can subtract the 96 and subtract the 43 from 180. And when I do 180 minus 96 minus 43, I'll be left with 41. We're going to skip to number 6. Number 5 is very similar to the one we just did. Just a hint on this one, if you were to go do this, remind yourself that that is 90. Okay, so number 6, the triangles aren't attached in the same way, so you have to use some old information to do that. What we'll first do is we can try to find measure of angle 1. If you look at that triangle, we know all three angles in there. So the measure of angle 1 plus 61 plus 68 has to equal 180. If I subtract 61 and 68 from 180, I will be left with 51 degrees. Okay. If you recall from previous lesson, those are vertical angles, and vertical angles are congruent. So if I know the angle opposite of 2 is 61, then I know angle 2 has to be 61. We didn't have to subtract or add or anything to do that. And then if you look at this right angle, I now have all three angles. I have the measure of angle 3 plus this 90-degree angle plus angle 2, which I just found is 61. And those add to 180 degrees. So I can just solve for the measure of angle 3 like I've been doing, isolating it. And when I do 180 minus 90 minus 61, I'll get 29 degrees. A hint on number 7 is bisects, which means if BC bisects angle ACD, that angle 2 and angle 3 are going to be equal. Okay, they're going to be congruent. So what happens there is for angle 2 and angle 3, together they add to be 90 degrees, but it's bisected, so I have to split it equally. And so half of 90 is 45, so I know angle 2 and angle 3 are 45 degrees. Right? So then if I know angle 2 and I know angle 3, I can use the triangle sum theorem to find angle 1 and angle 4. If you look at the triangle here, if this is 45 degrees, I can do 180 minus 48 minus 45 to find the measure of angle 1, and I'll get 87. And then I can look at my other triangle here, and I can do 180 minus 83 minus angle 3, which is 45, and do that subtraction, and I'll be left with 52. So then we'll keep going. You can see different ways that these problems can be set up. All right, let's look at number 9 because it brings in a different concept. It has our parallel lines, which is helpful. So you might keep in mind that we might use alternate interior angles, alternate exterior angles, corresponding angles, consecutive interior exterior angles, which you just took a test over. And so we'll have some of those to talk about. If you look, some of the ones that jump out at me are angle 1 and this angle here are alternate interior angles, so they're going to be congruent. And I can do angle 4 because this angle and this angle are going to be congruent. Okay, and if I have this is 49 and that is 73, I can find angle 2 by using the triangle sum theorem, which means I will subtract them from 180. And to find angle 2, I'll subtract those, and then I'll be able to get 58. Okay. To find angle 3, this is a linear pair, 3 and 73. So I can do 180 minus 73 for angle 3, and I will get 107 degrees. And angle 5, we also have another linear pair, 180 minus 49, and that'll be 131. So we use a lot of our old information along with our triangle sum there. So just remember, even on number 11, you have parallel lines. You might have some of those angle pair relationships. Let's look at number 10 together. All right, we have quite a few right triangles all combined in here. So we'll have to come up with some ideas on how to do that. One thing I notice first is angle 6 is part of a right angle, and I know part of that right angle is 52. So 6 has to be what's left over in that angle. So to find angle 6, I can do 90 minus 52, and I will get 38 degrees. Well, if I know this angle, then if you look at this triangle here, I have two of those three angles, so I can find the missing angle 5. I can do 180 minus the known 86 minus what we just found as 38 to find angle 5. So angle 5 would be 56 when I complete that subtraction. That's helpful to find angle 1 because angle 5 and angle 1 make a 90-degree angle together. So I have a total of 90 degrees in that angle, but I've used up 56 with my angle 5, so that for angle 1 would leave me with 34 degrees. Okay, so that we have that. So now I want to switch colors real quick just so we can see it a little better. But we have this right triangle here, big right triangle. And I can find angle 2 using that bigger right triangle because I have this 38-degree angle on the bottom left. I have a right angle on the top left, and then I have my missing angle 2. So all the angles in a triangle always add to 180 degrees. There's a missing 90 and the 38, so take those away. So that to find angle 2, I'll do 180 minus 90 minus 38 in that triangle, and that will leave me with 52. Okay, so we're about only 2 left. All right, so then angle 3. If you look at angle 2 and angle 3, they too make a right angle. So together they're 90 degrees, so we have a total of 90 degrees. But we've used up angle 2's 50 degrees, so we'll subtract that away. And that will leave us with a remainder of 38 for angle 3. Last, we'll look at this angle relationship here. And those are a linear pair. So I can do 180 minus 86 find the measure of angle 4. And 180 minus 86 is 94 degrees. So we use some different ideas there with the right angle and linear pairs to solve that. Move down to number 12. We're going to solve for x, and then we're going to find the measure of each angle. So if you notice, we do have a triangle, and we are talking about all interior angles. So triangle sum theorem says all of these angles should add to 180 degrees. That's exactly what I'll do. I'll have 5x minus 2 plus 9x plus 3 plus 11x minus 21 equal to 180 degrees. So you're adding up all three angles. We need to combine our like terms. So I will look at my x values here that I have, and I'll add those coefficients. So 5 plus 9 plus 11 is 25 x's. And then I will add my constants, negative 2, 3, and negative 21, which will add to negative 20, still equal to 180 degrees. I will then add 20 to both sides. So I have 25x is equal to 200. And then I will divide both sides by 25 so that x is equal to 8. Okay, it does say in the directions we're finding 4 things. We're finding x and each angle in the triangle, which is 3. So we're going to have 4 total answers. So I have my 8, but I need to find the measure of angle D, measure of angle E, and measure of angle F. I can do that because I have equations for them. So angle D is 5 times x. In our case, x is 8 minus 2. 5 times 8 minus 2 is 38 degrees. Then I'll take the equation for angle E, which is 9 times x. So plug in 8 for x plus 3. I'll simplify that, and I will get 75. Measure of angle F has an equation of 11 times 8 minus 21, and that will be 67. So it's kind of the same thing we were doing before, but we have equations for our angles instead of just values for our angles. 13 will be much like that if you notice they're all 3 interior angles of a triangle. If you look at 14, we do have an exterior angle of a triangle. Okay, this angle here is not inside the triangle, and we have the 2 opposite interior angles, meaning that we will be able to use the exterior angle theorem. The exterior angle theorem says the exterior angle, in this case 18x minus 15, is equal to the sum of the opposite interior angles, which is 13x minus 11 and 4x plus 1. And we are supposed to add them. And you will solve that. So these do not add to 180. These sum up the inside angles and equal to that outside angle. So I'm going to keep my left side the same for right now. But I am going to simplify that right-hand side. So 13x and 4x together is 17x. And negative 11 and 1 is going to be negative 10. Okay, I'll move my 17x to be my 18x. I have my x's in the same spot. So I'll have x minus 15 is equal to negative 10. I'll add 15 to both sides so that I have x is equal to 5. Well, then it wants me to find the measure of each angle. Since there is an exterior angle, the triangle itself has 3 inside, and it also has that angle outside. Okay, so CAB is this angle here. Okay, that is CAB. So I will do 13 times 5 minus 11, and that will be 54 degrees. ABC is this angle here. So I will do 4 times 5 plus 1, and that will give me 21. ACB is this angle here. And I can do a couple things. I can find the other side of the angle first, or I can just subtract from 180 to get those, because if you notice, I have angle A and I have angle B, and I'm looking for that angle C of that triangle. And so I can just subtract 180. So I'm going to do 180 minus the first angle we found, minus the second angle we found, and I will simplify that in order to find ACB, and I will be left with 105. Okay. DCB, I can plug in 5. Or I can just subtract ACB from 180 because this is a linear pair. So that's kind of your options there. Either way, you will get the right answer. And DCB will be 75 degrees.